Hello, a Rosie math teacher coming at you from my 4th period accelerated grade 7 math class, where today we are talking about lesson 11-7, indirect measurement. If you measure something directly, you stretch your tape measure out, or you put your meter stick beside it, yardstick, whatever, and you measure directly how tall something or someone is. I am 4 feet 11 inches, so it would not be hard to measure me. However, sometimes you might choose to use indirect measurements. We're going to learn about those today. Go to the top of this page. Number 1, Becky casts a 7-foot shadow at the same time a nearby mailbox casts a 4-foot shadow. Class, underline the length of each of their shadows. Becky's was how long? 7-foot shadow. The mailbox was how long? 4-foot shadow. Now we're going to use the relationship of the shadow of Becky as compared to the mailbox, and by measuring the shadow that is measured at the same moment in time, you all realize that as the sun is rising in the sky and then setting later, that at any given moment in time, it is casting a shadow for both a building and a mailbox at the same time, and that shadow is related to the original object in the same way, numerically speaking. So let's go ahead and try this. In order to find Becky's height, instead of measuring her directly, I am going to use the measurements I know from these two shadows, accompanied by the measurement I know for the height of the mailbox, and I will use the two associated measurements to help myself find the height of Becky. Are you with me? All right, here we go. So for the shadows, I would like you to look at the two shadows, and I want you to write a B for Becky, and I want you to write an M for mailbox. Now beside the B for Becky, what number shall we write for Becky's shadow? 7. Okay, for the what I know, this is where we're putting the shadow length. So 7 for Becky's shadow. We are showing the relationship between Becky's shadow and mailbox shadow. So what number shall I put in front of M? 4. So in other words, this line of 7-foot shadow is related to this line of 4-foot shadow in the same way that Becky's unknown height is related to the actual mailbox. So we're going to do a what I know, what I want to find comparison between these two ratios. So what label, class, do you know I want across from B for Becky?
B.
A B for Becky. What label do you know I want across from M for mailbox? M for mailbox. And where will I place the number 3? Since it's the height of the mailbox, I'll put it in front of the M for mailbox. Excellent. So what number? 3. What do you know I will do next to finish solving this in a moment?
Cross-multiply, divide by lonely.
Love that answer. Cross multiply, divide by lonely number. Class, you're going to save that until I let you open your Chromebooks in a moment to answer that. But that will have you off to a great start. Please look at item number 2. At the same time that a 6.5-foot tall teacher, oh my, a 1.5 feet taller than your teacher, guys, a 6.5-foot tall teacher casts a 9-foot shadow, a nearby flagpole casts a 31.5-foot shadow, and then they ask you how tall is the flagpole. Again, we're going to compare the two different measurements of both the flagpole shadow and the person's shadow. Are you with me? So the what I know, whenever there are shadows involved, guys, the what I know is always going to be the shadow measurements. How shall we abbreviate the teacher? How about a T? Can we put a T for the teacher's shadow? What shall we put for the flagpole shadow? 2 letters. FP for flagpole. What number goes in front of T for teacher's shadow? Say it if you know.
9.
They are showing you that it is 9 feet. So we're going to use 9 for the teacher. And we're going to use what for the flagpole shadow?
31.
31 and a half for the flagpole shadow, equaling, and when I set up my what I want to find scenario, remember earlier we were using the shadows here. What do you think I'm going to use underneath what I want to find? We're going to use their actual height, and I want this more concentrated under WIW. Okay, what letter goes across from T? Say it. T. What letter across from FP? FP. Now, they give me a height. Is it the height of the flagpole or the height of the teacher? How tall is the teacher?
6.5.
Where do I place that? In front of the T. In a moment, when I set you free, you will use your online calculator to do what? Cross multiply, divide by lonely number. And you will find the height of the flagpole. Now, I want to also point something else out to you. And I would like everyone listening and following along with what I'm asking you to do. I want you also to notice that in both number 1 and number 2, we are dealing with triangles that are similar. And because the triangles are similar, the shadow is hitting at the same angle. So that's why they're showing you the triangles that are similar. Let me point out how you can know. There's a thing called angle, I can spell angle, yes, angle. I almost thought I'd spelled angel accidentally. Angle, similarity. Here's how you can determine if two triangles are similar to each other. Do you agree that in number 1, we were given a right triangle here, and then we were given a smaller right triangle here? Yes? What did you notice in, not only in the corner here, was that marked as a right angle, therefore a 90-degree angle? Did you also notice that they gave us a single mark at the top, and they gave us a double arc at the bottom? So we can tell, in this case, that all 3 of these angles are congruent. If all 3 angles in 2 triangles are congruent to each other, we know the 2 triangles are what to each other? Not congruent, but just similar. Notice that also on the situation with the flagpole and the teacher. Notice how they gave you might not have realized this, but they gave you 2 triangles. I'll trace the black one. The black triangle is associated with only the flagpole, right? And they gave you a little tiny arc here, and they gave you a right angle here. Do you agree that they also gave you, on what I'm now going to trace in red, they also gave you this little triangle associated with the teacher, and it also has a little arc, and it should have, maybe it didn't, it should have the right angle arc, right angle box right there. So as soon as you see how many angles are are congruent. How many angles are congruent to each other? 2. As soon as we have 2 triangles where 2 angles are congruent to each other, then we know those 2 triangles are therefore what to each other? Similar. Once we know we're dealing with similar triangles, we can use all of our clues to get the missing measurement. All right, let's move on to item number 3, because there's a little tricky piece I want to point out to you. First of all, trace the big triangle that you see. I don't think you'll struggle with that, but go ahead and trace the big triangle that you see. I'm tracing mine in black. Okay? Now, do you see 2 measurements for the black triangle? Yes. One is the base, or the shadow, and one is the height against the building, right? Okay, now trace a smaller triangle. Do you see the smaller triangle?
No.
I find this interesting because the first time I looked at this problem, I was like, I just see a trapezoid. I don't see another triangle. Anybody with me? Anybody with me? Okay, how many of you do see the smaller triangle? I know where it is now because I cheated and looked ahead. Plus, yeah, once you think about it, you'll see it. Okay, do you agree that the smaller triangle is what I am currently tracing in red? Oh, do we hear the collective? Oh, now I see it. Okay, so in the smaller triangle, do we see a right angle symbol?
Yes.
Yes. Do we also see a double arc? Yes. Hey, is there a right angle symbol and a double arc symbol in our larger black triangle? Yes. So what do we know since we have two angles that are congruent from the red triangle to the black triangle? What do we know about the two triangles? They are therefore similar to each other, and we can therefore compare the measurement of coordinating sides to find the measurement of a missing but coordinating side. All right, so we know that the base of the black triangle is how long, guys? 20 feet. Do we also know the base of the red triangle? And here's where it might get only slightly tricky. If this whole base is 20 feet and this little measurement here is 2, what can I do with the 20 and the 2 to find this number?
Subtract.
I can subtract. Don't say it out loud, but write that number now underneath the red triangle. You do it all by yourself. I think you can handle it. 20 take away 2, write what it equals right there. And then set yourself up a what I know scenario, a WIK. Remember, at first we were doing shadows, right? Compare shadow to shadow. Give yourself a space where you're going to put a B for the big triangle shadow. Give yourself a space where you're going to put S for the smaller triangle shadow. So I will let you tell me this. Class, what number will I put for the bigger triangle shadow? 20. And the number you just wrote down for the smaller triangle, don't say it, but go ahead and put that in front of S for smaller triangle, equaling what I want to find. Guys, what do I want to find? I want to find the unknown height of my little red triangle, yes? Okay? Remember, we write same label across from same label, so what letter do I write across from B? B. Please write B across from B. What letter do I write across from S?
S.
S. Please write S across from S. Do you have a number that you could fill in for one of these? Yes. Remember, this column was dealing with the shadow lengths. This column is dealing with the height. I believe they give you a height. Now, obviously, this must be a Barbie doll dream house or something, because the height of the building is only 2.5 feet. That is really small, guys. So kind of odd. An example of how the real world problems are not always real world. Okay, so 2.5. Are you putting that in front of B for big triangle or in front of S for small triangle? B for big triangle. Then obviously you will what? Cross multiply, divide by lonely number. Okay, I want to give you a heads up on something dealing with item number 4. In the figure, the triangles are similar. They go ahead and tell you that, even though you can tell by all of the angle markings. What is the distance D, where I am measuring right here with my red line, from the water ride to the roller coaster, round to the nearest tenth? Let's point something out.
Miss Rose,
Yes.
can you check the K for checkout?
That child is not in my class right now. She is in my class during 5th period.
Okay, thank you.
Thank you. Okay, we're still continuing. Okay, number 4. What is the distance D from the water ride to the roller coaster, round to the nearest tenth? Now, circle all 3 numbers you've been given. Everybody right now, circle all 3 numbers. Did you circle 45? Did you circle 21? Did you circle 10? Were they all meters? Yes, so good. There's no worry about converting measurements. Now I want you to ask yourself this. When you look at these 3 numbers, can you find which lines map to each other? In other words, which lines are the same, the corresponding side as compared to another corresponding side? I'll give you an example. I'll go ahead and give you this. The line measuring 21 meters is the line I just traced in black. Is there a way we can determine if the line measuring 10 is corresponding to 21, or if the line measuring 45 is corresponding to 21. Now, to be fair, they each correspond, but in a different way. I want you to tell me the measurement of the corresponding line that is from the bigger triangle. So on the count of 3, tell me that measurement. 1, 2, 3. 45. Excellent. So in a moment, you're going to make a what I know ratio, and you are going to compare the bigger line, 45, to the smaller line, 21, across from your bigger triangle number. You will write, well, you will leave it empty because you want to find the height, D, of the bigger triangle. Across from the small side, 21, you will want to write what number for the height of the small triangle?
10.
You'll want to write 10. Then when you cross multiply and divide by lonely number, will you get the missing side?
Yes.
Yes. I lied when I said there was one more because there is yet another. I'm only going to give you this heads up when you get to number 8. Because they're asking you to find the measurement from the silver coins here to the gold coins here, when you have figured out the missing side I am tracing in green, what will you need to then add it to?
15.
The 15. All right. I hope this helps. You may begin. Do your best.